We have a triangle PQR, and the three medians are drawn. So a median is a line from a vertex to the midpoint of the opposite face, and we're told that they all intersect at the point G. The medians are divided into a ratio of 2 to 1 at this point G, so this is twice as long as this is half as long as this, twice as long as this. And we want to prove that GP, so this vector here, plus GQ, this vector here, plus GR, this vector here, is equal to 0. So the sum of these three vectors all equals 0. What I'm going to do is I'm going to give these points where the medians intersect, I'm going to give those names. So let's call this, I don't know, let's go with A, B, C. Okay, so now we know some stuff like QA and AP are equal, PB and BR are equal, QC and CR are equal. So that might be useful. And we know some other stuff, right? Like GA is half of RQ. And actually, let's write some of that stuff down. Let's write that GR, so that's this vector here, is twice as long, so that would be 2 times AG. Similarly, how did I write that last time? I wrote GR, so okay, I'll write GQ. GQ is equal to 2 times B, what's the one in the middle? G. And GP is equal to 2 times GP. No, not, that's what I just wrote, GP, AG. So really what I just wrote down was this 2 to 1 ratio thing, right? I wrote that the medians were in a 2 to 1 ratio for all the medians. Okay, so now let's look at what we're trying to prove. We're trying to prove that the sum of these is equal to 0. So let's just take these vectors and just start playing with them. Just change them into equivalent vectors. See if we can get 0. So what does that equal? Alright, GP, that's this vector here. Well, let's try writing it as this plus this, just for fun. So GP is equal to GA plus AP. So I got a GA, alright, GA. And that's kind of cool because I know GA in terms of GR plus G. Let's do this one too. Let's write. So that was this vector. Now let's see if we can do GQ. What could we do GQ as? GQ. Let's write that as the sum of. Well, we used this one last time, right? Let's use it again. Let's say GQ is equal to GA plus AQ. GA plus AQ. Maybe I'll put these in brackets just so we see that this is that first one, this is the second one. And you know what, let's leave GR. Let's not change them all. Alright, let's see if we can play with these some more. GA. Well, look at that. I got GA and GA. So let's leave those. Let's write 2 GA. If we have a GA, we're adding another GA, we got 2 GAs. AP, which one's that? AP and AQ. Oh, those are equal and opposite vectors, right? So let's leave AP. So that's the AP. But AQ is this vector here, which is the same as QA, which is the same as AP. So, or sorry, which is the negative of AP. So negative AP. This vector AQ is equal to the opposite of AP, right? It's equal to PA. Plus, then I left that one. Whoop, I got two things canceling. That's pretty good, right? That's kind of what we wanted. Right, we're trying to get to 0, so I got rid of some of the stuff. So 2 times GA. Oh, look over here. That would be equal to 2 times negative AG plus GR, which would be 2 times, negative 2 times AG plus GR. But what is AG, or what is 2AG? 2AG is equal to GR. Therefore, negative GR plus GR, we'll refer to vector, equal to the 0 vector. So this original sum is equal to the 0 vector. So we're good. We proved it. You might look at that and say, well, it looked like magic, right? How did I know to change this to this and this to this? I was just playing with stuff, right? I just took this original thing and I just started expressing it in terms of different things, trying to make it look like these ones that I already knew, and like it was just sort of playing with it in the right way. So there's other ways you could have proved this. I don't even know, maybe there's faster ways, but you could have done this question differently for sure if you played with it a different way. But if you play with it enough, you should end up getting the 0 vector as the sum.